So we're still in the trigonometry algebra book, the one that we're using just for their chapter 5. So this is chapter 5, section 2, where we're going to start talking about trig functions. Now, when we start talking, this slide is a lot, okay? It's very overwhelming, but I want you to just focus on things I'm going to highlight to you, okay? So first of all, we're talking about the trig functions that you learned in the past. You learned about sine, right, equals opposite over hypotenuse. You learned about cosine, and you learned about tangent. And at that time, you learned SOHCAHTOA, okay? And we said, hey, SOHCAHTOA is a great thing for you to remember because basically it means that the sine of some angle, okay, is equal to opposite over hypotenuse. That's what the O and the H equal. The cosine of an angle equals the adjacent side over the hypotenuse. Now remember, this is always the opposite and adjacent refer to legs of a right triangle. So the tangent of an angle is the opposite leg over the adjacent leg. And your hypotenuse in a right triangle, you know it's always the same. It's neither adjacent nor opposite. It's always the hypotenuse. So this is the same sine, the same cosine, and the same tangent as from back in geometry when you learned about it, okay? Now, what we learned today is a little bit different thing about sine, cosine, and tangent, and I'll get into that after. But what I want you to kind of focus on is these that we're looking at here that maybe you've never learned before. Now, CSC, that refers to cosecant, okay? SEC, that refers to secant, and COT refers to cotangent. And these ratios are similar to the sine, cosine, and tangent. They're trig functions the same. And what they are is they are reciprocals. Okay, so reciprocals of these. So the reciprocal of the sine, I'm going to flip it. So if I was doing it in the old traditional way, I know that the cosecant of an angle is going to be then the hypotenuse over the opposite. I know the secant of an angle is going to be the hypotenuse over the adjacent leg, and the cotangent of an angle is going to be the adjacent leg over the opposite. So again, you know all of these, you have to learn these. And once you know the ones on the left, remember all you have to do is flip them to get the one on the right. So the hardest part, I think, is recognizing what goes together, and how I did it was I know the letters don't match. So sine is S, so I know cosecant, which starts with a C, goes with sine. I know cosine starts with C, so the reciprocal starts with S. That's just kind of how I learned it. So again, I know if it's sine, it's cosecant. If it's cosine, it's secant, and tangent and cotangent, well, those are just obvious, okay? So what else is different about the ratios and how we do them is in the past, we just did a random triangle. So like, for example, you just happen to have a right triangle, and we'd say, you know, we'd label it like A, B, and C, and then we would say, what is the sine of angle B? And so you'd say, okay, well, here's angle B, this is my opposite, and this is my hypotenuse, and you would do that. So, you know, you'd put the length of, let's say, AC, right, over the length of AB, or whatever. Again, opposite over hypotenuse. And so it was just kind of like a random triangle in the middle of nowhere, and you would just identify the opposite and the adjacent. And now we're going to do trig functions a little different. We're going to place those triangles in a coordinate plane. So you're going to have an X and Y axis. You know, here's your Y axis, your vertical line, here's your X axis, your horizontal. And we're going to basically identify some point that's going to lie in one of the quadrants. Now, in coordinate planes, you know it's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And the quadrants are really important in trig. They make a difference in how your answer is going to go. And so it really does matter that you understand your quadrants. But if I give you, let's say, an ordered pair, like in this first example that happens to lie in quadrant 1, you know that ordered pair has an X and a Y value. I might just give you, let's just say that this ordered pair is 3, 5. Okay, so what that tells me is if I just take this point at 3, 5, and I drop down this perpendicular line to my x-axis, always to my x-axis. No matter what quadrant I'm in, I'm going to drop a vertical line to the x-axis. And when I do that, I think you might recognize or notice that if I draw a line from the origin to that point, and again, I draw a line from the origin to this point, you're going to see that what you created in essence was a right triangle. That line down is a right angle, obviously. And notice now you have a right triangle. You're always going to be utilizing the angle that is created between this terminal side and the x-axis, okay? So this is the angle that I'm going to be looking at. We call that angle theta. We've talked about that, I think, before. So we know this unknown angle is theta, and notice that your opposite side is going to be the y value from your original ordered pair. If you think about it, I'm going to travel in the x direction this way, and I'm going to travel in the y direction that way. So yeah, my x and my y are now the lengths of my two legs. And notice that the opposite leg is the y value, and the adjacent leg is the x value. And that is going to be the case every single time. My hypotenuse, we're going to call it our radius. I'll explain why it's called a radius, but it's always r, okay? So notice if let's say I have this large angle here, theta's like, whatever, maybe theta is 110 degrees, right? Well, when I take this point that's over here on the end, if I drop it down again to my x-axis like I told you need to do, you create this right angle, and this is the angle we're going to look at, and this angle is the opposite again is y. And the adjacent of that angle is still here, and my hypotenuse is still my radius. If I go into the third quadrant, like in this picture, and I have an x and a y value that take me here, when I go back up to my x-axis, it's always the x-axis, notice that I'm going to have a leg from here to here, that's x, right? And I'm going to have a leg from here to here, that creates my y. And again, this is the angle I'm looking at, and here's my opposite y over my, not over, but I have my opposite y, and I have my adjacent x, and my r is always my hypotenuse. So when I create this triangle, always knowing that my vertices is here at the origin, okay, in every case, and I create this perpendicular line back to my x-axis, I'm going to always have y as my opposite, x as my adjacent, and r as my hypotenuse. So if I take that and I go back here to this, where we talk about sine, cosine, and cosecant and all that, instead of opposite over hypotenuse for my sine, I'm going to do opposite is y, hypotenuse is r. Cosine, adjacent over hypotenuse. Well, adjacent is always x, and r is always the hypotenuse. And tangent, opposite over adjacent. Well, y is my opposite, and x is my adjacent. So again, now we learn that in this type of math, now that we're doing it on a coordinate plane, our opposite is always the letter y. Our adjacent is always the x. And it's not letter y, it's the value of y, right? It's the y in an xy coordinate. And my hypotenuse is always the radius. And you might say, well, where does radius come from? Because I don't even see a circle here. And you're right. Eventually, we're going to get to the point where we are going to sort of create this circle around here. And you're going to find that this hypotenuse is represented by, or this radius of this circle with a center at the origin in this case, is the hypotenuse of this right triangle that we create within it, okay? And so we're not getting to the circle yet or anything like that, but that's where the R comes from, okay? So I think this is enough for this slide. We'll talk a little bit more as we move on. So let's try to find the 6 trig functions using an XY combination, and let's try to figure out how we would solve some of these problems. It says the terminal side of angle theta in standard position passes through the point 8, 15. So let's just first plot that point and kind of get an idea. So again, the terminal side, that obviously it means this is the, the initial standard position just means I'm going to start at that red arrow on the x-axis, and I'm going to go to point 815. My terminal side is going to go through 815. Well, I know coordinate 815, this would be 8, right? Let me take this a little higher, make it look a little bigger. And then let's say this is 15 here. So 815 would be here, okay? So I know my x is 8, my y is 15, got that. And so let's do my second side then of my angle, right? Or let me do it in red. So my terminal side goes through that point. So that's what I've got right now. I've got this point 815. I have this arrow, this ray that goes through it. And I have this angle now that has been created in here called theta, right? What I'm going to do is I'm going to drop a line from this point down to my y-axis, or my x-axis rather, and I'm going to have this right angle there. So now I know, right, that my x value, I know this coordinate 8 is here on the number line, but I know that this leg right here is equal to 8. I know that this leg going down is equal to 15, and I know that my hypotenuse is r. So I can use the Pythagorean theorem to find r, because I know that a squared plus b squared equals c squared. One leg is 8, the other leg is 15, and the radius is my hypotenuse. So when I do the math, I'll kind of go a little fast. This is one of those triples that we probably will remember after we do enough of them. But when I do it, I'm going to get that r is 17. Okay? And so now I have all the three values I need to identify my 6 trig functions. So I'm going to erase this, and I'm going to start identifying my 6 trig functions. So I know the sine of theta, again, is opposite over hypotenuse, y over r, which is 15 over 17. I know my cosine of theta is equal to x over r, which is going to be 8 over 17. And I know that my tangent of theta is opposite over adjacent, which is y over x, and it's going to be 15 over 8. And I know that the other three are just reciprocals. So cosecant is going to be r over y, or 17 over 15. I know secant of theta is going to be x over r, or 17 over 8. And cotangent of theta is going to be x over y, which equals 8 over 15. And these are the 6 trig values, okay, that we are looking for. And that's it. That's how you do it. Again, we go to the second one. It says the terminal side of angle theta. It's a lot of words, but you see they all ask the same thing. In standard positions, my angle starts here, and it passes through the point -3, -4. So let's identify where that might be. -3, 2, 3, 4. So -3, -4 is here. Okay, so I know I'm going that way. And yes, theta is this angle right here. It's that whole thing, right? However, what I need to focus on is the right triangle that I'm creating. And the right triangle, like I explained before, always goes from that point perpendicular to the x-axis. So there's my right angle, okay? And this is the angle that I'm going to utilize, okay? I'm basically creating this right triangle right here within this whole thing, okay? I'm going to utilize this angle. I know my y value is always my, let me kind of write, -3 is the, now again, I know x has a value, right? Like in this problem, x is -3, y is -4, and I'm looking for my radius, right? So -3, -4, and my radius. So again, I'm going to use Pythagorean theorem to get started. So I'm going to start over here, and I'm going to do a squared plus b squared equals c squared. A squared is -3 squared, b squared is -4 squared, and c squared is r squared. So 9 plus 16 equals r squared, 25 is r squared, and so r equals square root of 25, which is 5. And again, this is a 3, 4, 5, a gold common triple, definitely one you would know. And again, the radius is always positive, okay? So I have this positive radius now. I have my three values for my x, my y, and my r, and now I'm able again to find my 6 trig functions. So coming back, I know my sine of theta is going to be opposite, which is, again, or opposite over hypotenuse, but you might want to get used to saying y over r. I know that my cosine of theta is x over r, and I know my tangent of theta is going to be y over x, which is 4/3. And then my reciprocals. So my cosecant of theta is 5 over negative, or negative 5 over 4. My secant theta is going to be negative 5/3. And my cotangent is going to be negative 3 over negative 4, which again is 3/4. Okay? And so again, I found my 6 trig values, and that's really the answer. Now, you notice some of your trig values are positive, some of your trig values are negative. And so one thing that we probably should discuss is about in what quadrants are the functions positive and what quadrants are they negative. So I'll kind of go over that in the next slide. So in this slide, we have a little bit of an issue because we have these angles that we call quadrantal angles. And what happens is that they fall on the actual axis themselves. So, for example, if I'm plotting, like they're talking about a 90-degree angle, right? Well, a 90-degree angle, here's one leg, here's the other leg, right? And let's say I have a point here, right? Well, I can't really draw a right triangle. Like a right triangle down to the base is kind of weird. It doesn't really give me, this becomes the right angle. It's just kind of weird, and it doesn't really work great. So what we try to do, we have like a different method we choose when we do these angles, okay? And so what we do is we tell you, well, you know that if you have a 0-degree angle, you're going to start on this terminal side, and you're also going to end. You're basically not having an angle at all. So what we do is we tell you, find a point on this line, on this, where this terminal angle or terminal side would be. Now you could do 1, 0, 2, 0, you could do 3, 0, but we really teach you to just focus on 1, 0, basically the value 1. So if I go up to this 90 degree, if I have a terminal side through here, I'm going to give this point 0, 1, okay? Then if I did a 180-degree angle, I know I would be over here, okay? It'd be like this, right? It would end here, and I'm going to do negative 1, 0. And if I go all the way around to down here, 270 degrees, I'm going to give it, that point would be at 0, negative 1. And then if I came back around and did a 360-degree angle, meaning I did one complete revolution, I would be back here again, and again, it would be 1, 0. So we want you to use these 2 points. So x is going to have its value. You know, you're going to get x and y off of this these 4 values, and your r is always going to be positive 1. So you'll see how easy it is once you kind of, first of all, you memorize and you really understand how to set this up with these coordinates, okay? Definitely super important. And then let's work it out. So sine of 90 degrees. So again, we're saying a 90-degree angle. Well, a 90-degree angle would have its terminal side here, which means we're talking about 0, 1. So x would be 0, y would be 1, and r is always 1, okay? So your sine is y over r. So 1 over 1, or just 1. Your cosine is x over r, which is 0 over 1, which is 0. Your tangent is y over x, and 1 over 0 is undefined. Your cosecant is your sine flipped, so it's still 1 over 1 or 1. Your secant is your cosine flipped, so 1 over 0, which is undefined. 0 can be in the numerator, but 0 cannot be in the denominator. And your cotangent is 0 over 1, which is now 0. You're going to find that your answers for these quadrantal angles for all of these are either going to be 1, negative 1, 0, or undefined. As long as you use these values, you're going to see that it's always going to be equal to that. Okay? So again, let's try another one. So again, sine of 180 degrees. So again, what I'm going to do is I'm going to first draw the 180-degree angle starting over here. draw it, and I know my terminal side is over here, so this is the point I'm going to use, and this point is -1, 0. So for this problem, x equals -1, y equals 0, and r is always +1. So now I'm going to do my sign. So my sign is y over r, 0 over 1, or not undefined, just 0. Okay. Cosine is going to be x over r, so -1 over 1, which is -1. Tangent is going to be of 180 degrees. That's going to be y over x, so it's going to be 0 over -1, which is 0. And then my cosecant is the reciprocal, so 1 over 0 or undefined. -1 over 1 is 1 over -1, it's still -1. And my cotangent is going to be -1 over 0 or undefined. And again, those are my answers. So I do want to talk about, notice again, you got your answers were one of the 4 things that we talked about, right? All of your answers were either 1, -1, 0, or undefined. Now, let's talk about your answers positive and negative wise with regards to not quadrantal angles, but rather just regular angles that kind of fall in the quadrants themselves. Okay, so let me move to another slide. Or actually, let me just move down. So let's say that I have this angle here. Let's do a coordinate plane. Okay, and again, we know this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I'm going to teach you just something to help you. It says all students take calculus. Okay? All students take calculus. And if you can remember this, this is going to help you. This is going to tell you which trig functions of the 6 are positive in which quadrants. So what this means is A for all. So all trig functions are positive. Or all trig values. Let me say trig values. All trig values are positive. And I'll talk about that why after, okay? In the second quadrant, okay, sine is positive, and obviously cosine would be negative, and tangent would be negative. And now again, if you think about it, if the sine is positive, it means its reciprocal is also positive. And if the other ones are negative, it means their reciprocals are cotangent, sorry. It means the reciprocals are negative. So again, only sine and its reciprocal, cosecant, is positive in this one. Now t in quadrant 3, obviously that means only tangent and its reciprocal are positive. So then that would mean sine would be negative here, so would cosecant. Cosine would be negative here, so would secant, right? And tangent is what would be positive, and cotangent would be positive, because again, that's what the t represents there, okay? And then in the last one, the c represents cosine. So cosine is positive, as is its reciprocal secant, okay? So sine would be negative, cosecant would be negative, tangent would be negative, and cotangent would be negative as well, okay? So this is going to help you to figure out what is positive and what is negative in each one. And again, just think about why that would be. I don't have to explain it to you every time, but if I have something in here, right, in my triangle, x and y are both going to be positive, and radius is always positive. So if all remember, my trig functions are y over r, x over r, and x over y, or y over x rather, right? These are sine, cosine, and tangent. So if both of these are positive, the fraction's positive. If both of these are positive, the fraction's positive. If both are negative, it's positive. If any of these at any point, if one is negative and one is positive, depending on the quadrant, it's going to affect the outcome. So here, if x is positive, y is positive, and r is positive, all my trig functions are going to be positive. When I go into quadrant 2, okay, my x is negative, my y is positive, and my r is positive. So anything that deals with y and r together i.e. sine and cosine, is going to be positive. Anything that has x in it is going to end up being negative. Okay, and I can kind of prove that as I go to all of them. And so that's where this comes from. These reciprocal identities, this is just, we know that, when we learn sine, we know that sine and cosecant are reciprocals of each other. The formal way to write it is sine equals 1 over the cosecant. Okay, cosine equals 1 over secant. And again, this is sine and cosecant. These go together. These two go together, and these two. Okay. So let's do a couple more problems from this section, from that lesson. So it says, find cosine of theta if secant theta is 5 over 3. Okay, well again, I know that secant and cosine are reciprocals of each other. So if the secant is 5 over 3, then the cosine of theta is going to be the reciprocal, which is 3 over 5. And it's that easy. I just flip it because I know they're reciprocals. I know that cosine of theta equals 1 over secant theta. And if I do the math, notice I'm going to get the same thing. 1 over 5/3, which I could rewrite as 1 divided by 5/3, which means it's 1 times 3/5, which equals 3/5. And so again, I got that answer without having to do all that work. So I can write it as this, but I would rather just take this and just flip it. It's just that easy. Again, sine and cosecant, I know these are reciprocals of each other. So it wants me to find the sine, being that the cosecant is negative square root of 6 over 2. So I know the sine is negative 2 over square root of 6. Now I do have to rationalize that denominator, so I do have a little bit of work to do. So 2 radical 6 all over 6, which can be simplified to negative radical 6 over 3. And that would be my answer. So at this point, I'm going to stop the video. This was day 1. Okay, so this is end of day 1 in our class. And I know there's going to be an assignment probably covering this part. And then the second part of this video falls under day 2. And we'll go to that now.